What you're seeing is not just a rocket. It's a rocket that was made in a 3D printer from scratch. But the most important question is, will it actually fly and reach space? Let us introduce you to Terran 1. The world's first rocket made in a 3D printer. In 5 years of development, engineers made 85% of its parts, exclusively 3D printed. Even the first stage was built entirely from printed pieces. Now you might be wondering, how do you actually print a rocket that flies into space? It will definitely need printable and, most importantly, strong materials that can withstand various forces. Well, the company behind the rocket, called Relativity, chose 2 key materials that make every rocket you know possible for flight. Those are proprietary aluminum for the body and a special blend of copper, chromium, and niobium, NASA's invention for 3-piece engines. Now it's time to print the rocket, although it doesn't use any glue to make the rocket. And thankfully, this printer has 2 methods of printing. The first one is laser powder bed fusion, which lays down layers of powdered material and then uses laser zapping to glue the whole thing together. It's a near-perfect technique to make strong and detailed parts. The second one is directed energy deposition, or DED. The head of a printer uses both a laser and a nozzle that blows powdered material at the same time. As the head moves around the object, the laser literally melts tiny bits of the material, and the nozzle deposits some powder into that new melt. It's great to make large pieces of the rocket, but it's terrible at detailed pieces. However, their teamwork makes the dreams work. And this dream came true on March 22nd, 2023. The rocket, consisting of 85% of 3D printed materials, took off into space. That's good news. But the bad news is the second stage engines failed to ignite and help the rocket reach orbit. However, the rocket still succeeded in surviving through max Q. This is what scientists call the specific place where the rocket experiences the most stress when going through the atmosphere. Needless to say, it really went through without shattering into millions of pieces. Still, there is a question that needs to be answered. Why even bother using a 3D printer? Let's say you need to rework a part of the rocket, but the process is pretty annoying. You'll have to send it back to the manufacturer, redesign, refit, and reproduce a new detail. With a 3D printer, you just change a code and hit print until it makes the perfect part. 3D printers are generally faster than any manufacturer that could spend months on making one signal, while a printer could make it in a week or 2. And don't get us started on the price. If you ask a professional in 3D printing, they'll always praise the cost efficiency. The 3D printer started from gluing small toys to making rockets that can now reach space and revolutionize the aerospace industry. Maybe we will even see the first astronaut flying a 3D printed rocket, assuming we find one who won't be scared of it.